Hi there, let's begin. This is APES Chapter 19 lecture video part 3. Now let's talk about extracting fossil fuel deposits. Well, primary extraction is when you drill down, you generally set up a pump at the top. What does the pump do? It pushes air down. That air creates pressure, which hopefully can push, the pressure will push up the oil to the surface. That's a traditional. This is primary extraction. Well, secondary extraction is where they actually create an injection well, a separate well next to it. And in that well, they inject things into the ground. Well, what do they inject? Water or natural gases, different things. And solvents are generally, says the solvents are used here, these chemical solvents in tertiary, but your book called it secondary, so we're going to go with what your book says. Secondary extraction uses these solvents, these water, the steam, and this creates pressure down below, and that pressure down below will help inject. That pressure will help push more of the deposits towards the surface. It's a very expensive process. It's more expensive than primary extraction, so they generally do not use it that often unless the cost of these fossil fuels goes up. So when the cost of fossil fuels goes up, secondary extraction comes into play. So this is not always used. It's only used when it's more cost effective. Directional drilling, what is that? That is when you drill for a well and you don't go straight down, you start going sideways or horizontal. Why is it a good thing? Well, because you only have a what's called a drill pad, and that one drill pad could lead into many different directions. You won't have drill pads everywhere trying to get into rock straight below. So it actually is technically good for the environment if there is such a thing when you're drilling for a fossil fuel. It's more efficient because you're only drilling from one area. They make more money. They're really doing it's all about money. It maximizes profits. It can help the environment because you have less drill pads on the surface, but in reality, you're still shouldn't even be going after those fossil fuels in the beginning. Hydraulic fracturing. Now, this has another name called fracking. This is what they do to this is what they're using nowadays to remove natural gas deposits. So it's hydraulics using different water with different things dissolved in it to fracture or to break rock. So they inject water down, and the water, the sand, and the chemicals that are injected down, they crack rock structures. The sand and the small glass beads penetrates these rock structures and keeps the cracks open so that this gas that's trapped within these rocks can actually leave through those cracks that stay open as a result of the sand and the glass beads. Basically, it's really bad for the groundwater. Look, here's where your aquifers are, and you go below the aquifers for this to happen. So the potential of contamination in the groundwater is very high. You're talking about solvents. A lot of them, some of them get pumped back out and they end up in nearby areas and they pollute groundwater. So this is called fracking or hydraulic fracturing. This is the most common method that they're using nowadays to mainly extract natural gas, but they're using it for oil also, but it's mainly used for natural gas. Offshore drilling, very dangerous. This is an offshore drilling platform. Why is it dangerous? You're dealing with the ocean and the salt, the energy of the waves. You're dealing with a lot more elements, a lot more potential for danger. Sometimes it's in cold waters. You're dealing with ice. It's challenging to maintain a structure. And the thing is, once you drill into the ground, you now have a hole in the earth that you cannot just plug up. So now you're talking about holes in the earth in the open ocean areas or in the ocean areas or shallow seafloor areas that are potentially can be problems down the road. Really, really, really big problems down the road. Basically, we're exploiting new fossil fuel sources. And I already explained this to you. We basically are looking at oil shale. Now, why are we using oil shale today and we weren't using it in the past? Because of the energy return on investment of oil is getting lower and lower and lower. Why is it getting lower? Because we're having a much more difficult time finding. We're having to drill in farther places. So because of oil's energy return on investment dropping and dropping, we are now able to utilize those other resources. Japan is the only country using methane hydrate, but that's potential for the future. So, how does fossil fuel use impact the environment? Well, we're in an environmental science course, so let's talk about it. First up, miners, they are exposed to a lot of dangerous environments, collapsing mines, inhalation of dust, inhalation of gases. It's pretty nasty work environment. That's one potential impact of coals. Big time erosion. I mean, look what the land surface looks like afterwards. There's nothing covered. There's no plants. Nothing is anchoring the soil anymore. Massive erosion. You have a lot of exposed metallic rock material here that is also going to make its way into a nearby water. It's going to form acid mine drainage. Sulfide minerals in the rocks are going to react with rainwater. This stuff leads, when it dissolves in water, it becomes sulfuric acid, which is a strong acid, and it causes acid shock in nearby water bodies, destroys soil nearby, destroys terrain nearby. Major habitat destruction here. Major habitat destruction. Hydraulic fracturing. What does that do? Well, we just spoke about fracking a second ago. Those fluids can mess with aquifers nearby. Methane is coming upwards, can get into the aquifers also, as I showed you in that picture earlier. You're talking about methane being released in the air. It's not so easy to harvest all of the methane that's get released from there. You're also releasing VOCs, or volatile organic compounds, during this process. The water you injected down there with those salts and those little glass beads is contaminated and polluted. Needs to be stored somewhere afterwards and put somewhere. And injecting into the ground like that causes minor earthquakes. If you were to look at the U.S. Geological Society's earthquake map, you will occasionally see earthquakes in areas like Oklahoma, or areas where they are doing a lot of hydraulic fracturing, and you'll notice them earthquakes popping up in the middle of a tectonic plate where you don't normally expect to find earthquakes. And a lot of that has to do with the geological shifting due to everything they're pumping into the ground for hydraulic fracturing in that part of the country. Oil sands, those are very ecologically damaging. And that's because in order to extract it, you got to cut down forests, a lot of overwater usage, a lot of wastewater is released in extracting the oil sands and dissolving those oil sands, and creating the mixture where you have to take it off the top. So you have a lot of water usage it is polluted water, basically. How do you transport them? Well, they're generally put in rail cars or by tankers of sorts. That's how you transport these things. You can have potential problems. We have pipelines. Pipelines can break. Tankers can burst. Common problems. Terrorism with these types of things is a common problem. People don't really ever think of that, but a lot of terrorists will go after pipelines and things of that nature just to create havoc in a place. The Deepwater Horizon, you need to be familiar with this one. In 2010, BP, British Petroleum, had an offshore oil platform called Deepwater Horizon. It exploded. There was a malfunction and there was an explosion. What happened? Well, the systems failed. So there was literally a hole in the ground that oil was just leaking into the Gulf, and it was 3 months of it. What did it look like? The oil that was coming out of the ground looked like tar mixed with clay. This is what's covering this pelican in this picture. So this was, we would watch it on the news. There was video footage of it just pouring out of the ground. It took their engineers months to figure out how to plug it back up. It created scares all around the planet because there's old platforms all over the planet. A lot of these are not being used anymore, and they're rusting and they're sitting there and no one's maintaining them. And the same thing could happen in other parts of the world or even the United States again. What did it do? A lot of people, and by the way, this is the Gulf of Mexico, in case you're wondering where it happened. The shellfish was contaminating the area. That's a major shellfish hub for the United States. The beaches were destroyed. Tar was everywhere. This stuff's carcinogenic. It's really nasty. A lot of the animals in the area died. It was very, very polluted for a long time. Right? We will stop this lecture there.